This is Algebra 2, Year 2, Section 11.6, Day 2. This is where we were graphing our data and finding how many standard deviations it took to include all of our data. So for problem 1, we're told that the mean price of a nonfiction book on the bestsellers list is 25.6 and the standard deviation is 3.1. So they've already found your mean and your standard deviation. That's these two numbers. And we need to plot all the data values and determine the whole number of standard deviations from the mean that include all the data points. So we're going to create a number line. And I'm going to count by 2's on my number line. And again, yours doesn't have to look exactly like mine. As long as it includes all the information, it doesn't really matter. So I just started at 16, counted by 2's, and went to 36. Now what we're going to want to do is plot all of our data values. So we have a 27, and again this is with x's on the number line, and we'll just stack them up if we have repeated values. Then we have a 23, we have a 24, a 25, a 30, a 20, another 25, a 24, a 28, another 25, a 32, and another 24. So that should be all of your data values plotted on the number line. Now to find the standard deviations that it takes to include all of those values, we're going to use our mean and the standard deviation that they found for us. So we want to plot our mean is at 25.6. So that's going to be like in between the 25 or the 20 where we have our 25s plotted and our 26. And we put a dotted line there just so we can see it a little better. So we know that this is 25.6. That was our mean. Now to find standard deviations, we're going to take that mean value. So we have 25.6. And to go to the left, we're going to subtract. And we're going to subtract 3.1 because that was our standard deviation. When we subtract our standard deviation from there, we get 28.7. And remember, one whole standard deviation goes to the left and to the right. So we want to find the right-hand side. So we're going to take our mean again, 25.6, and add 3.1. Oh, sorry, this is wrong. When we subtract from 25.6 and subtract 3.1, we should get 22.5. Sorry. Now when we add the 3.1, that's where we get the 28.7. So that's our first standard deviation away from the mean. So we want to plot both of those deviations. So 22.5 is going to be right here in between the 22 and the 23. And then the 28.7 is going to be a little over halfway. Oops. We have like an imaginary 29 here, so a little over halfway to 29. So that's our first standard deviation. This is 28.7. This is 22.5. And remember, these are both 3.1 away from your mean. So that's one standard deviation. Now, we still have values that are outside of those deviations, so we have to find a second deviation. So to find the left-hand side, we're gonna take our 22.5 and subtract 3.1 again. And that'll give us our second deviation. That's gonna give us 19.4. And then to find our right-hand side, we're gonna take 28.7 and add 3.1 again. That's gonna give us 31.8. So again, we wanna plot those as dotted lines. So 19.4 is a little bit before the 20. So that's 19.4. And then 31.8 is just a little bit before 32. So this is our 31.8. Now we still have a value that's outside of those standard deviations, so we need to find another standard deviation away. So we're going to take 19.4 and subtract 3.1 again. That's going to give us 16.3. And then take our 31.8 and add 3.1 again. And that's going to give us 34.9. So again, plotting those with dotted lines, 16.3 is just a little bit past the 16. So this is 16.3. And then 34.9 is almost halfway between 34 and 36. So this standard deviation is our 34.9. So now all of our values are included within those three standard deviations. Remember, this is one deviation, that's your second, and that's your third. It takes both directions to make a standard deviation away from the mean on your graph. So it wants us to tell them how many deviations it took. So it took three deviations to include all values. Number 2, we're doing the same thing. This time our mean is 37 minutes. And our standard deviation is 12. So again, we want to plot all of these points on our number line. And I'm going to count by fives. Again, yours doesn't have to look exactly the same as mine. And I just extended the number line. It's a little small, so. And I'm going to start at 0 and count by fives. So we're going to plot our values. We have 27. So that's almost halfway between the 25 and the 30. We have a 30. We have a 47. 35. Another 30. A 40. Another 35. 22. And a 65. So that's about where your data point should be. Now again, we need to find deviations, how many deviations it takes to get all of our values within. So we're going to take our 37, which is our mean, and we're going to plot it on our graph first. So that's almost halfway between 35 and 40. So this is our 37. That's our mean. Now we're going to take 37 and we're going to subtract 12 to get our left-hand side first deviation. And that gives us 25. And then 37 plus 12 will give our right-hand side deviation. And that gives us a 49. So that's our first standard deviation away from the mean. So plotting those, 25 is there, and 49 is right there. We still have values that are outside of that first standard deviation, so we need to find a second. So we're going to take 25 now and subtract 12, which gives us 13. And we're going to take 49 and add 12, and that gives us 61. So that's our second deviation away. So plotting 13, there's 13, and 61. And again, we still have a value that's outside of our standard deviations that we found, so we need to find another standard deviation. So we're going to take 13 and subtract 12, which gives us 1, and take 61 and add 12, which gives us 73. So we're going to plot 1, and then 73. So those are all of our standard deviations. So again, we have 1 standard deviation, 2 standard deviations, 3 standard deviations to include all of our values. So it took 3 deviations again. On the top of the next page, we're given a new set of data. This time we need to find our mean and our standard deviation. You can do that on your calculator. You're going to punch in your data set and you're going to look for your x bar and your sigma x when you find it on your table. You should get for your mean 82.3, and your standard deviation or your sigma x value is 4.3. So now for B, it's asking us how many values fall within 1 standard deviation, within 2 standard deviations, and within 3 standard deviations. So we're going to draw our number line like we did in 1 and 2, and then we're going to count the values that are within each standard deviation. So again, you want to make your number line, and I'm going to extend this number line again because they are kind of short. And then okay. So I'm gonna start counting at 77. Okay. So then we need to find standard deviations. So we're gonna find, so we wanna plot our points first. So 83.8 is gonna be almost to 84 there. 87.1 is just past 87. 92.5 is right in the middle there. 80.6 is gonna be a little past halfway. 82.4, 77.6, 78.9, 78.2, 81.8, and 80.1. So for this one, our data is kind of spread out a little bit, but it should look about like that. So now we want to find our standard deviation, our first standard deviation. So that's going to be taking 82.3 and subtracting 4.3. That'll give us our left-hand side. That's going to give us 78. And then taking 82.3 and adding 4.3. That gives us 86.6. So on our number line, we want to plot our mean value, so our x bar, and that was at 82.3. So our mean value, this was 82.4, so it's going to be just to the right, or just to the left of that value. This is 82.3. And then we're going to plot our standard deviation. So 78 is right here. That's 78. And then 86.6 is right here. So now what it wants us to do is count up for the first part, how many data values fall within that first standard deviation. So we're going to count the values that are within those bars. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 values that are within one standard deviation. Now we need to find our second standard deviation. So we're going to take our 78 and subtract 4.3 again. That again will give us our left-hand side. That's going to give us 73.7. And then we're going to take 86.6 and add 4.3. And that's going to give us 90.9. So again, we want to plot those now. So 73.7 is going to be off of our graph. So we'll just kind of put it over here and say that that's 73.7. And then 90.9 is almost to 91. So this is 90.9. And now, again, we're gonna count the values that are in between those bars, so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So there are 9 values that are within 2 standard deviations. And then within 3 standard deviations, we still have 1 point that's not in our first 2 deviations, so this one might get included in the third. So let's find the third first before we say that. So we have 73.7 and we subtract 4.3. That gives us 69.4. And then 90.9 plus 4.3 gives us 95.2. So our 69.4 again is off of our graph, and we don't have any more points that way anyway. So it would be off to the left here somewhere. And then 95.2 is going to be a little bit past 95 here. So this is 95.2. And that does include our last value. So now for our for 3 standard deviations, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So there are 10 values within 3 standard deviations. And then our final question is just an analysis. It says, one of your friends says that the data below fall within 3 standard deviations from the mean. Your other friend disagrees, saying that the data fall within 6 standard deviations from the mean. With whom do you agree and why? So looking at our graph, our mean is right here, and we have deviations to the left and right. Now, this is important because we need to remember that a standard deviation from the mean goes from the left and the right. So this is 1 deviation, this is 2 deviations, and then a 3rd deviation. So we should agree with the friend that says there are 3 deviations, that they fall within 3. So 3 deviations. And that's because 1 standard deviation is above and below the mean. So this is basically to remind you that 1 standard deviation is on the left-hand side of the mean and the right-hand side. So there are 2 parts to a standard deviation. It's not just 1 single line.